So hope you all have seen the last four videos which I had shared on YouTube. Now this is the next discussion, which is on binary tree traversal. So binary tree traversal is nothing but, or tree traversal is nothing but visiting each node in a tree exactly once is called as tree traversal. So I will have to visit each node. This is kind of operation on tree. Okay, you have studied some other data structures like stack, queue. So there were some operations, right? Push and pop for stack. Then for queue, it was insert, delete. Similarly, these are some operations kind of thing for trees, binary trees, which are which is what we are going to discuss in today's class. So there is something called as in-order traversal, there is something called as post-order, and there is something called as pre-order traversal. That is what we are going to see in the today's discussion. Okay, we are going to study traversal. Now, there are different methods of traversal, or there are different methods of traversing a binary tree which are possible. So binary tree, you all already know that a tree which has maximum two children, or a tree in which each node should have maximum two children, that is called as a binary tree. So I will give some names here for these nodes. So A is a root node. I will use a short form for root as RT. This is left child and C is right child. Okay. Now the traversal which we are studying are pre-order traversal. Okay. Pre-order traversal. Now pre-order traversal meaning if I have to traverse a tree using pre-order, then the sequence is something like this. I will have to visit root node first, then I will have to visit left node and then right node. Okay. Then another or second method is in order. So in case of in order traversal, I will visit left node first, then root, then right. Okay. Last thing is post order. So in case of post order traversal, I will visit left first, then right, and then root. Okay. If you want, you can make a note of this. Pre-order traversal, I will visit root left, right. In order, I will visit left, root, right. And post order, I will visit left, right, and then root. For remembering this, it is very simple. This LR is always like this, meaning first it is left and then right. Left is always to your left, right is always to the right, left and then right. Now, these things here in order or in which traversal, I have a word here. What is this pre? What is this in? What is this post? Now, this pre, in, and post, they're telling the location of root. So pre means it is before. So location of root is before. In means it is between. Post meaning it is afterwards. So here is what root is. Okay. So hope this is clear now. So these are the methods of traversing a tree, traversing a binary tree. Pre-order, in order, and post order. Three methods. There will be a sure short question on this in your exams. Okay. And then there is some other topic called as binary search trees, wherein you will create a binary search tree and then you apply these orders and then like for some purpose, meaning for example, if you apply in order traversal for a binary search tree, it will give you the list of elements which are in sorted order. There are some applications also of these traversal. As of now, we'll just discuss about these three ways in which I can traverse a binary tree. Okay. Now to understand this further, say if I ask you to give me a pre-order traversal of this particular tree, okay, what it will be or what you should write is pre-order traversal meaning I should visit my root first, then the left subtree, and then the right subtree. So root I will visit first. So root is what? A. So I will write A over here. So I am traversing this tree in pre-order traversal. I will get the result as A. Then I should visit left. I should visit left child, which is nothing but B. So I write B over here. And then I should visit the right child, which is C. So ABC is nothing but it is pre-order traversal. I have visited route first, then the left child, and then the right child. Is that clear?
Yes, sir.
Okay. Next is in-order traversal. You keep concentrating on this. Uh, we take some more examples. You solve the last example in today's class. You will be very much comfortable. Okay. Next is in-order traversal. So for in-order traversal, I will have to visit left node first. So what is left node? It is B. So I write B over here. Then I should visit root. So root is what? A. So I write A. And then I should visit the right node, which is C. So BAC is nothing but in order traversal of this particular tree. Next is post order traversal. For post order traversal, it says I should visit left node first, then right. So left is nothing but B, right is C, B, C, and finally root, which is A. So this BCA is nothing but it is post order traversal of this particular tree. Is that clear? Yes, no? Okay, okay.
Yes, sir.
So let us take some example which is there on the slide or in your textbook. So this example from your textbook which I refer. So I will just take this example and later we'll try to take some easy example so that you also can solve it. Now here we had only in this tree we had only meaning a root node and there were two children. Now if this child has further children here, then how we should solve it, that we'll have to see. Okay, so we'll better take this example. So there is a tree given over here, wherein there are some uh, operators here, and then there are meaning these are nodes which have some value. So there is a plus here, there is a star operator here and here. So this is some expression which is there in the tree. Okay, so I want in order traversal of this. So what is in order? We have already seen. It is what? Left, root, and right is my in order. Okay. So I start from this particular point. Now this says that in order traversal, what it says is I should visit left subtree first. So left subtree is this particular portion. Okay. So I come to this particular portion. Here, this is my root node again. I should visit left side. So for this node, this portion is again the left subtree. Okay. So similarly, I come to this portion is subtree. I come to this particular thing. This particular node is my left subtree. I come over here. Now there is no, I should visit the left subtree, but there is no left subtree here. Okay. So there is nothing to visit. Then I come back to the node. So I write A. Okay. I write A. Then I will have to visit uh, root. So root I have visited, which is A. Then I have to visit what? Right. Right, there is nothing over here. So this particular portion is visited. It is taken care. So now left is over. After left, it is what? Root. So I will have to visit this slash. Okay. Visit that division operator. So this is done. Left is done. Root is done. Now I should go to the right part, which is B. So I write B over here. Now left is visited, root is visited, right is visited. Now this is completed. Now this was nothing but, so this I am doing recursively. This was nothing but left side for this star. Okay. So for left I have visited, I should visit star. So I just mark star over here. I have visited left, I have visited root, I should visit right now, which is C. So after the star operation, I write C. Now this is done. This was nothing but it was a left sub child or left sub tree for this particular star. So I will visit root now. I will visit that star. Left is done, root is done. Now I will visit what? Right. So D comes over here. Now this entire thing was left side or plus operator. So left is done. I will come to this root. So plus I have marked. Left is done, root is done. I come to right. Now here, if there was a subtree, I would have gone there, but there is nothing. Left is not there. So I come back to root. I write E there. There is no nothing on the right side. So that's it. So I have traversed the tree completely. This is my in order traversal. Okay. This is my, or it is given here also. You can just cross verify. What we have got here and what was given on the slide is same. Okay. So this is in order traversal. Hope you have understood till some extent. Once you do one or two examples on your own, you will be comfortable. You could get it? Yes, no?
Yes, sir.
Okay. Others will need some time. This is very easy actually. Once you become perfect in this, easily you will grab 6 marks in your exams. There will be a sure short question of 6 marks. They will give you a tree, and then they will ask you to give these traversals. So you will have to write this, and this particular thing. This level order you can just ignore as of now. Okay. Next we will see pre-order traversal. So pre-order, what is the sequence? Can somebody tell me?
Root left, right.
Correct. Pre means it tells the position of root. So it is root, left to the left, right to the right. So this is the traversal for pre-order. Okay. Now I will have to visit root node, which is nothing but plus. So I will write plus first. Then I will visit what? Left. So I will visit this particular part. Now this particular part is already a tree, meaning this is a tree. So here again I will have to visit root. So I say star. This root is done. I will come to this portion. So this is also a root. I will write another star. Then I come to the left part. Left part is another tree. So I visit the root first in that tree. So I write a slash. Then I come to the left again. This is the root. So I write A. Then root is done. There is nothing on the right. So this root was done. This left is done. I should visit right now. So I write B over here. Okay. So this is the sequence. So I've come till B. Next, this left root was done. Left is done. I should visit right. So I write C. Root is done, or this entire thing was left. Root was done. Left is done. I should visit to the right. So I write D here. And then finally, root is done. Left subtree is taken care. I should visit the right. So I write E over here. Okay. So this is how is the pre-order traversal. Okay. I will just try to clean this so that I can explain post-order traversal. I will just check if somebody is waiting. So we'll check this post-order traversal now. So post-order traversal, what is the sequence? Can somebody tell?
Left, right, root.
Correct. It is left, right, and root. Okay. So now if somebody has not understood, please concentrate. So this, we are traversing a tree using post order traversal. This is the sequence: left, right, and root. As I said, left is always to the left, right is to the right. Root tells, meaning where the root should be, that tells this traversal itself. So post meaning it should be afterwards. So position of root is afterwards. So this is, in this sequence I have to traverse this tree recursively. So I know that this is the sequence. We start from the root node. We always start from here. Now the sequence tells me what I should visit left first. So this is a root I should ignore. I should visit left. But left, if you see, this is a subtree. Okay. So same rule is applied again. I should visit left, meaning I should visit this particular part. Okay. So this is again a subtree. I should visit the left child or left subtree. This is again a tree. So I should visit the left subtree. Now this is not a tree, it is a leaf node. Okay. So I should write it. Okay. So I have reached this node. So I should note it down. So left is visited. Okay. A is visited. After A, I should visit what? Right. So right is what? B here. So I will visit B. Left is done. Right is done. After that, I should visit what? Root. So I write a slash over here. Okay. This part is taken care. This part is taken care now. But this was what? Left child of star. Okay. So should I visit star now? No. Because the traversal says after left you should visit right. So left is taken care. Right is nothing but this portion. So I will write C over there. Now left is visited, right is visited. The time is for the star mark, or which is root. So I will visit this particular portion which is star mark. Now this portion was nothing but left child for this star over here, which is at this position 2. Okay. Left is visited. Should I visit root now? No. The traversal says I should visit right. So I come over here. This right is nothing but D. So I visit that. I just note it down, or if you are doing this in terms of program, you will have to just print it. Left is taken care, right is taken care. We will have to visit root now. So the star mark, I will just note it down here. This entire thing is taken care now, but it was what? It was a left subtree or left child of this particular plus mark. Okay. So left is taken care. Do I visit root? No, I should, this traversal, it says me, I should visit right node. So I will visit the right node, which is E. Okay. Now the left subtree is done, right subtree is done. I should visit what? Root. So I will write that plus mark over here. Now I have traversed the entire tree. So if you just compare it with the thing given on the slide, both are same. So this is what? Your post order traversal. Okay. Is that clear? Yeah. So we'll see how
Yes, sir.
we'll have to do this programmatically, and then we will come back to another example which you all will solve. Okay. So if you will have to write a recursive function for in order traversal. Now we know that in order traversal is left, root, and right. So if you remember this sequence, writing program also is very simple over here. It is just the recursive call. Okay. So in order is the name of the function. Void means it is not going to return anything. It will take a pointer of type this tree pointer. Now this tree pointer should be some structure or the user defined data type which is pointing to the tree. So tree, as I said, there was one way of implementing it which was with arrays. Okay. In the last video you have already seen this. One was with the help of arrays. Second was with the help of linked lists. Okay. Something like this. So we usually do this linked representation. Okay. For the subject, whenever we write a program, we will use this linked representation. So to represent this particular one node, you define a structure. Okay. You define a structure and then you give some name. So that name you can assume that it is this tree pointer, and then there are some things in it which is you need a left pointer or say left child. You need another pointer called as say a right child, and then there is some for data or information. Okay, whatever is your uh, data or information, that data type you can give either integer or character, whatever is there that you can give. Close the structure definition. So this structure definition you will have to write first. We'll see this program in detail. We'll see it later. But now, because we are looking at these three traversal, we'll see what are the functions of it. Okay, or how do we write? What code do I write in those functions? So return type is nothing. So void in order is the name of the function. There is a pointer here. So if that pointer is not null, meaning if there is if it has come to this point, then there is no need of further traversing. Okay. So I will just check that condition and I will come over here. I will call in order function. So it is recursive call. Same function I will call in order function. And first I should visit what? Left side. So I say visit left. Then root meaning I will just after visiting that I will just print the whatever is there in the data of root. I will just print that. So left is done, right is done. Right is what? It is just printed, and then sorry, root is just printed, and then I should visit right node. I should visit right node. So as simple as this. In this function also, if you see, there are two recursive calls for in order, which is going to call the same function, and then this wherever root is there, wherever root is there, that I will just print. That information I will just print. Okay. Similarly for the other two. So for this for post order. Post order is the name of the function. I called post order again inside this function, which is a recursive call. Same thing. I will visit post order. You all know the sequence is left, right, root. So I will visit the left side. I will visit the right side, or right subtree, left subtree, right subtree, and then the data. It is going to come in this sequence. Okay, we'll come back to this explanation of the entire program once again. But as of now, you just see this recursive functions how they are. So, and similarly, we'll have to do this was post. Similar is for pre-order traversal also. Okay. Now this is the exercise for you. This is the binary tree which you can see. Now you will have to note down this in your book and tell me what is the pre-order traversal of this, what is in-order traversal and post-order traversal. Note down this tree in your book, or you can just visually, if you are very quick enough, if you are very smart, you can just tell me what is the order, or what is the pre-order. What is in order and what is post order. For simplicity, every time if you want, you can write what do you mean by pre-order. So pre-order is root left, right? Or can you tell me the traversal?
AI.
Where is I? Okay. A, then I directly.
B.
Okay. A, then
B,
B. Okay.
C,
C.
No. How C?
Sir, A, B, D, I, J.
uh,
A, B, D.
A, B, D, I.
A, B, D, I. Correct. Next.
C. C.
C of J,
J,
Yep. Yep.
F.
C.
After F. Okay. C.
GKH.
G.
E,
G, K, H. So hope this is right. I have just noted down whatever you have said. I will just compare it. We will just see this later, okay, whether it is right or wrong. In order traversal. Now, can somebody explain and do this in order traversal? Unmute and can you explain? So in order traversal, it should be left, root, and right. Now, can somebody explain and then tell me? Can somebody make an attempt? You tell the sequence. You also do it as the way I am doing. You can just explain it to your classmates. Anybody? Yeah, so you at least tell, don't explain, at least tell the sequence. In order traversal. People are there? Connection lost?
IDJ.
Okay. Okay, hope everybody is trying it. So explanation in the sense I wanted it something like this. Now, in order is what? If somebody is not following, please follow this because there is a sure short question on this. There will be and there is a term work also on tree traversal. So in order traversal meaning I will have to access the left subtree first, then the root, then the right subtree. Okay. So I will start from root node. This tells me that I should traverse. Traversal is what? Visiting. Okay. It says that I should visit the left subtree. So left subtree is nothing but this particular portion. Okay. Now, can I visit the entire? Is it the node so that I can visit? No, it is the tree. Okay. So again, the same recursive definition is applied. So this is what root. Now for this subtree, this is root. So I should visit what? I should visit the left node. But then this is not the left node. It is left subtree. Okay. This is the tree again, which has this D as the root node, I and J. Now here for this particular tree, can I apply this in order traversal? Yes, I should go to the left node. Now here, do I have anything on the left, anything on the right? No, there is nothing. So left, there is nothing to visit. I should visit root, left, root, and then right. Okay. So left, there is nothing. I should visit root now. So I note down IO. This is done. Right, there is nothing. So this portion is done. There's nothing but left. So left is visited. After that, I should visit root, which is nothing but D. So I write D over here. Left is visited. Root is visited. I should visit right. So I write J over here. This entire thing was left, that is visited. I should visit root. I write B. Then I should visit right, which is F.
Yes.
This portion is done. Yeah. Then this portion is done. This was left node. I should visit root,
A.
which is nothing but A. I note it down. Now left is done. Root is done. I should visit right. Okay. I should visit right. But is it a single element? It is again a subtree, wherein this is my root node. So I should concentrate on the left node. Left is what? G. So here, is it a single node? No. It is a tree again. This portion is a tree again. This is root node. Do I have a left node here? No, there is nothing to visit on the left. So I visit root. I note down G. Okay. Left there is nothing. I visited root, which is G. I should visit right now, which is K. I note down K. Left is visited. I should visit root, which is C. Left is done. Root is done. Now right, which is H. Okay. With this, I have visited everything. So that's it. This is the in-order traversal for this particular tree. Similarly, you can try out post-order traversal. So any doubts in this? Anybody has any doubts? I can just repeat something. Anybody has any questions?